So these are all questions that will require you to be good at the difference of squares factoring technique. And the difference of squares is always something squared minus something else squared. That's what the difference means, that in between the two squared things is a subtraction sign. And since they're both squares, you have one squared thing minus another squared thing. And it always works out to be 1 plus and 1 minus. And if you think about checking it, it's basically you've got a first term, a last term, and your outside and inside have disappeared. Look what happens when I multiply my first ones here. A times A. Do I get A squared? Look at my last ones. B times a minus B. Do I get a minus B squared? Yes. And what's my outside? My outside is negative AB. My inside is positive AB. Those are like terms that cancel out. So difference of squared is the same idea of foiling like our other trinomial, but it's just a unique situation where the outside and the inside always cancel each other out. And it allows us to do a bit of a shortcut for factoring. So like we did yesterday, you could let A equal this, let B equal this, and do a substitution. However, I think you could, here, I'll write it out a little bit more space here. For B, I'll write it out 3x plus 4 squared minus, so I have something squared, and I have a minus sign, and I have something else squared. So when I factor it, it'll be 1 with a plus in between and 1 with a minus in between. I'm going to use little brackets here. This one would have 3x plus 4 and 3x plus 4. And the second one is 2y minus 1 and 2y minus 1. Those are the two things that are squared. So notice that I have 1 with a plus, 1 with a minus. If we multiply this out right now, do you see that your first ones, this times this, would give you 3x plus 4 squared? Do you see that your last ones, this times this, would give you a minus 2y squared? And if you look at your outside and your inside, they would cancel each other out because they're exactly the same, and one is positive and one is negative. So what ends up happening is students start to say, I can recognize when I have a difference of squares. And I can always factor it as, like we did in the first one, A plus B, A minus B. The same things with 1 plus and 1 minus. Remember, these were called conjugates of each other. We used them in our last unit when we had to rationalize the denominator, and the denominator was a binomial. Okay? Now, what happens in B is after we factored it, we're like, ooh, but inside my brackets, I have some like terms. Like the 4 and the minus 1. Can you see those could go together? So we could write this as 3x plus 2y, and 4 minus 1 is plus 3. And the second one, I have 3x minus 2y, and here this negative sign would distribute, so I'd have 4 plus 1. And so there's my final answer, but I could only get that if I recognize the difference of squares at the beginning. And a difference of squares only works if it's something perfectly squared minus something else perfectly squared. So when I get to part C, I look at it, and I don't have something perfectly squared. Because it's 27 something times something. Well, it is, but not a nice number. Same thing, 75. There's not a nice number, like it's not 8 times 8. It's not 9 times 9. Doesn't quite work out. So we can only use the difference of squares factoring if it's a perfect square minus a perfect square. And in C, this one isn't quite yet. However, in C, I'll scroll it up so we can see it. can see, if you look at, this is term 1, and this is my second term. Do you notice they have something in common? Anytime we have a common factor, we can pull that out. What number divides both 27 and 75? It's the biggest number that you can pull out of there. 3. So I pull out that 3. Put a big set of square brackets. If I pull a 3 out of 27, I'd be left with 9. And I still have 2x minus 3 all squared. Minus, if I pull a 3 out of 75, I get 25. And I still have the y minus 4 all squared. So I use the square brackets just to pull out the 3. And now I notice that the inside so a lot of math is about recognizing stuff. How quickly can you see a difference of squares? I see the difference. The 2x minus 3 is squared. Now the 9 out front is 3 times 3. The y minus 4 is squared, but now the 25 out front is actually 5 times 5. This makes a perfect difference of squares. So how do you factor a difference of squares? I'm going to put it, you're going to have the same thing, one with a plus sign, one with a minus sign, right? The first one is going to be a 3, because that's, to square would be 9, and you have a 2x minus 3. The second one is going to be a 5 and a y minus 4. So again, 3 and a 2x plus 3, and a 5 and a y minus 4. Right? Because if we check, this here is this times that. This right here is this times this. And with the color coding there, like abstractly, can you see the difference of squares? Like it's purple plus orange, purple minus orange. And it's the purple is a perfect square, the orange is a perfect square, and we have a difference. All of this, now we check, can I simplify inside any of these brackets? Well, this would be 6x. This will be plus 5y. I'm going to have a minus 9 and a minus 20. Give me minus 29. Second one. 3 times 2x will give me 6x again. Minus 5 times y. Now I have a minus 5y. I'm going to have plus 9 plus 20. Oops, I have a mistake. Thank you for those of you that almost saw it. You see that I wrote that down wrong? Should be the exact same thing, 2x minus 3, 2x minus 3. So I have a minus 9 plus 20, that will be plus 11. And this would be our final answer after it's simplified. So we recognize things as differences of squares. It can make our life easier. All right, questions for practice are 12, 13, and 14.